All right, here we are at the conclusion of Chapter 4. We're at Section 4.8. And what we're talking about is that same thing we started Chapter 4 with, the quadratic formula. Let's get a little refresher. And I know you guys are hoping to hear me sing again because it was so beautiful. And much to my surprise, I was not discovered on YouTube to be the next American Idol. So you get to hear me again. Here we go. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a All right. And the discriminant part of that is right here. This is called the discriminant, the stuff that's underneath the square root sign, the b squared minus 4ac. And what the discriminant does for you is it tells you how many answers you're going to have, 1, 2, or 0. And we'll kind of show you that in a minute. So we use the quadratic formula to solve quadratic equations. And so if you have something ax squared plus bx plus c equals 0, then you can solve the quadratic equation using the quadratic formula. Let's take a look at how that might work in a real problem. When we're looking at this thing right here, x squared plus 7x equals 6, the first thing you have to do is get it into proper form. And so proper form would be having 0 on one side and everything else on the other. So we're going to subtract 6 on both sides. And then we find what a, b, and c are. A is 1 because we have a 1x squared right there. B is 7. C is negative 6. And so if I go through the whole deal, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. And if you multiply the stuff inside of here first, you do the discriminant first, you're going to get 49 minus 4 times, and 1 times negative 6 is just negative 6. Ends up being the square root of 49 plus 24 is 73. So we have the square root of 73. That's what's on the top. On the bottom, you got 2 times 1, so you just have 2. And so you have negative 7 plus or minus the square root of 73. So what does that result in as answers? Well, it's going to be negative 7. When I say plus or minus, I literally mean plus 70, the square root of 73 over 2, which in my calculator, if I typed all that in correctly, I got 0.77. You should probably practice typing that in yourself and make sure you get that. But the other one is x equals negative 7 minus, because it's plus or minus, the square root of 73 all over 2, which if I put that in my calculator, I end up with a negative 7.77. All right? That's how you do those, and there's a lot of different reasons why I did it in the order I did, and I'll be able to show you that as we go here. Let's take a look at example 2. Now, example 2 is going to work out a little differently, so keep your eye on it. Again, find your A, your B, and your C. It's already set in proper form. So my A is 2, my B is negative 8, and my C is 8. And so if I put that all into my quadratic formula, I get x equals the opposite of b plus or minus the square root of b squared. Now watch that, negative 8 squared minus 4ac all over 2 times a. All right. So I have negative 8 squared is 64. I'm going to always start inside here, the discriminant. I always do that first. And so when I have negative 8 quantity squared, that's 64. And then I have minus 4 times 2 times 8. Well, 4 times 2 is 8. 8 times 8 is 64. I have 64 minus 64. My discriminant is 0. Now watch how this changes. I now have 8 plus or minus the square root of 0 all over 2. Well, the square root of 0 is 0, and 8 plus 0 is just 8. So 8 minus 0, also 8. Okay? So 8 plus or minus 0 is just 8. 8 divided by 2 is 4. And so I only have one solution when my discriminant is 0. That's nice to know. Now remember, on the last one I had two solutions. My discriminant was positive. So that's a pattern a little bit. Positive equals two solutions. 0 equals one solution. All right? Let's take a look at this next example, example 3 here. In example 3, I have to first get the 5 on the other side, first step. So I got 0. And if I look at my A in this situation is negative 1, my B is 2, my C is negative 5. Here we go again. X equals the opposite of B plus or minus the square root of B squared minus 4 times A, which is negative 1, that's important, times C, which is negative 5, also very important. You don't want to mess it up. All over 2 times A, and that's 2 times negative 1 on the bottom. If I do my discriminant first, I have 4, which is 2 squared, minus 4 times negative 1 is negative 4. Negative 4 times negative 5 is positive 20. Wow. Well, 4 minus 20 is negative 16. And luckily, we just learned about how to find the square root of negative 16 is 4i. So my discriminant has an I in it. That means when my discriminant is negative, I have 0 real answers. Okay, 0 real answers. And so what I end up with for an answer here is negative 2 plus or minus 4i divided by negative 2, that 2 times negative 1. Since 2 goes into everything, I can simplify that. 2 goes into here once, goes into here twice, goes into here once, and it's a negative 2. So negative 2, and sometimes it might be easier for us to split this. Let's split it real quick. Negative 2 over negative 2 plus or minus 4i over negative 2. That results in 1 plus or minus. Now the negative sign won't matter here because it's plus or minus, so it just becomes minus or plus. 1 plus or minus 2i. Those are my answers. 1 plus 2i and 1 minus 2i. That gives me 2 solutions there. Okay, you guys take a few moments and go ahead and do questions 1 through 4, and I'll do a couple of them with you, or for you in a moment. So pause and practice. All right, welcome back. Hopefully you were able to at least find your A, your B, and your C on all of these. If you were not able to find A, B, and C, go ahead and pause again. Maybe you didn't know where to start from. Go ahead and pause again and just try to find your A, your B, and your C, because that's the most important part. So go through and find the A, the B, and the C on all of these. All right, hopefully you now have done that. And once you found your A, your B, and your C, that makes life a little easier. So for number 4 here, your A is 1, and your B is negative 3, and your C is 3. For number 2, you see how that's not written in the right form, so we're going to subtract 7x on both sides, and we're going to add 25 to both sides, and we're going to end up with 4x squared minus 20x, because 13x minus negative 13 minus 7 is negative 20, plus 25 equals 0. So my A is 4, my B is negative 20, and my C...
Davis, could you please come to the switchboard at the principal's office? Thank you.
There's another announcement for you. Over here, I'm going to add 16, so my A is 2, my B is 12, and my C is 16. And down here it's already written 3, -6, and 6. And so finding the A, B, C is the hardest part. And then once you find your A, your B, and your C, you just have to plug them all in and get answers. So on the first one, I hope you were able to plug it into the quadratic formula and get -4 and -2. On the second one, there was only one answer because that discriminant was 0, and you got 5/2. On the third one, you had 2 non-real answers, 1 plus or minus I. In this one right here, pretty tough one, you probably had 1.5, but it's 3/2 plus the square root of 3 over 2I. That's probably a tough one. Give yourself a pat on the back if you came up with that one. Now, there's ways to do this on your calculator, and if you Google or YouTube quadratic formula for my TI-83 calculator, you'll see a great way to do that. Maybe I'll put a link to that on my website. Now, using the discriminant, this is what we just talked about. When you do the discriminant and when b squared minus 4ac is greater than 0, you're going to have 2, and get this, real, that word is important, real solutions. The graph has 2 x-intercepts. That's why you have 2 real solutions. If I graph this thing and it equaled 0, it would just have 1 real solution. And kind of the way to think about it on that first one, the graph does something like this. 1, 2. And you have a solution here and a solution here. On the second one, the graph does this. Comes down, kisses it, and goes back up, and you have 1 real solution. On this third one, when it's negative, you have 0 real solutions. And when you think about having 0 x-intercepts, all that means is that the graph is up here, and it doesn't ever cross this axis. So let's see what that means on example 4 here. On example 4, when you look at just the b squared minus 4ac for all of these, for a, b squared, 36, right, b squared, 36 minus 4 times 1 times 5, well, that's 36 minus 20. You're going to have 2 solutions. On the next one, you have 36, again, b squared, 36, minus 4 times a times c. Well, that's 36 minus 36. You're going to have 1 solution. And on the last one, you have 36 minus 4 times 1 times 13. And you see the intercept is what's really changing everything. You end up with 36 minus 52. And so you're going to have 0 real solutions. Or it crosses 0 times. If you graph, if you put y equals to each of these, you'll see that on the graph. Go ahead and try to do 5 and 6 on your own to give yourself a moment to do that. All right. All they wanted you to do is find the discriminant on each of these. So you got b squared 64 minus 4ac, which ends up being 4 times 17. Find the discriminant and tell me how many answers you have. Well, on this one, I have 64 minus 68, that's -4. That's going to give me 0 real solutions. This one, I have 16 minus 12. That's going to be 4 positive. I'm going to have 2 real solutions. This one, 2 squared is 4. B squared minus 4 times -1 times -1. Well, that makes 1. 4 minus 4 is 0, so I have 1 solution. And here I have 36 minus 16. That's 20. That gives me 2 real solutions. That's it for the whole chapter. So I'm glad we were able to do this whole thing online, all chapter long. Thank you for sticking with me. And the test is coming up. Good luck.